Okay, students, today's topic is permutations and combinations. Let us discuss permutations and combinations today. One second, let us start the class. Be done in few different ways. Then two words can be done in equal different ways. Okay, fundamental principle of counting. Next one is permutation. Each arrangement that can be made by taking some or all number of things is called permutation. Permutations when repetitions are not allowed. If n comma r are positive integers and r less than or equals to n, then the number of permutations of n distinct things taken r at a time is n factorial divided by n minus r factorial. It is nothing but npr. So what do we say here? npr, right? npr is equals to n factorial divided by n minus r factorial. Okay, understood about fundamental principle, permutation and permutations when repetitions are not allowed. Here fundamental principles also, we have two kinds of fundamental principle: addition principle of counting and multiplication principle of counting. So here what they have given, there is nothing but multiplication principle they have mentioned there. And here all odd digit numbers that can be formed using 0 is one digit among the given n digits, then we get the sum of the odd digit numbers that can be formed using the given n digits including 0. So here 0 to 4 digit numbers formed with these 4 digits. So in that case what we have to do here, 4 minus 1, okay, p 4 minus 1, right, sum of the given digits 1 plus 2 plus 3, 6 times and so on, 1 1 1 multiplied by 4 ones. Next, from this what we have to subtract, 3 digit numbers we have to subtract, because if 0 is in the first place, then 3 digits will come, right? 3 digit numbers will form, but here we need only 4 digit numbers to sum. That is the reason we have to subtract 4 minus 2, p 4 minus 2 times sum of the given digits is 6 and 1 1 1, because 3 digit numbers. Yeah, that is what they are explaining here. And if you see the properties here, if n comma r be natural numbers and 1 less than or equals to r less than or equals to n, then npr is equals to n minus 1 pr plus r times n minus 1 pr minus 1. then NPR is equals to n factorial divided by n minus r factorial. Okay, first NPR. NPR is what? N factorial divided by n minus r factorial. That equals to what we have to prove? N minus 1 PR plus r times n minus 1 PR minus 1. So let us take this RHS. Here we are taking RHS. This is RHS. And simplify this. N minus 1 PR. N minus 1 factorial divided by n minus r minus 1 factorial plus r times n minus 1 PR minus 1. That is n minus 1 factorial divided by n minus 1 minus of r minus 1 factorial. So what do we get here? N minus 1 factorial divided by n minus r minus 1 factorial is there. Let it be. And plus r times n minus 1 factorial by n minus 1 minus r and plus 1. So plus 1 minus 1 gets cancelled. N minus r factorial you can get there. So here n minus r minus 1. Okay, n minus r minus 1 factorial, and here n minus r factorial is there. So let us convert. Here they are doing like this. They are converting this n minus r minus 1 factorial into n minus r factorial, because if we have the same denominator, then we can get the numerators easily. We can simplify the numerators easily. For that purpose, they are multiplying both numerator and denominator with n minus r. They multiplied both numerator and denominator with n minus r. So that what they are getting, n minus 1 factorial times n minus r divided by n minus r factorial, and plus r times n minus 1 factorial divided by n minus r factorial. So n minus r factorial is the LCM. And here we have n minus 1 factorial, here also we have n minus 1 factorial, take it outside, then n minus r, and here plus n minus r, here plus r, n minus r plus r, minus r plus r gets cancelled, n minus 1 factorial times n divided by n minus r factorial, which is equals to n factorial divided by n minus r factorial, that is nothing but NPR. Okay, let us see the short answer questions. Very short answer questions are there here. NP4 is equals to 1680. First let us factorize this 1680. If you factorize this 1680, what do you get? You can get like 3 times, yes, 1680 factorization we have to do. If you do the factorization, 2 8s are 2 4s are 0, again 2 4s are 2 2s are, again 2 210 times, again 2 105 times. Now 3 table take, 3 3s are 3 5s are, next 5 table 5 7s are, 7 table 7 1s are. So here 1 2 3 4 2s are there, 2 to the power of 4, and only 3 we have, only 5 we have, and only 7 we have. So 7, here NP4 is there. What is NP4? NP4 is nothing but n factorial by n minus 4 factorial. N factorial by n minus 4 factorial means what? N times n minus 1 times n minus 2 times n minus 3 times n minus 4 factorial, which is divided by n minus 4 factorial. N minus 4 factorial, n minus 4 factorial cancel. So what are we getting here? N times n minus 1 times n minus 2 times n minus 3. We are getting NP4 is equals to product of n, product of 4 consecutive numbers starts from n. Product of 4 consecutive numbers starts from n. So in that way we have to form the numbers here. Here 7 is the bigger number than 7. Before that 6 is required. Here one of the 3 is there, one of the 2 is there. Then 7, 3 2 is 6 we have taken. Then 2 to the power of 3 is left. Here 2 to the power of 3 more. After taking 1 2 from 2 power 4, then 2 power 3 we have. And here 5 also there. Then let us use 5. So 7 times 6 times 5 is there. If we move forward, we have to get 4. If we come back, we have to get 8. But in our hand, more 2 to the power of 3 is left. So 2 to the power of 3 can be placed here. So NP4 is nothing but 8 times 7 times 6 times 5. then that is nothing but n times n minus 1 into n minus 2 into n minus 3. By comparison, we can get n is equals to 8. That's it. Okay. Similarly, next question, np3. np3 is equals to 1300 and find n. Same model. Next question number 3. n plus 1 p5 to np6 is equals to 2 is to 7. Find n. n plus 1 p5 and np6. Yeah, what is n plus 1 p5? n plus 1 factorial whole divided by this is what 5 factorial, no? n plus 1 minus 5. That means n plus 1 minus 5 is n minus 4 factorial. This is a ratio actually. So ratio means into I can write. Numerator will become denominator. What is numerator? N factorial. Numerator is n factorial. And the denominator is n minus 6 factorial. N minus 6 factorial. Which is equals to 2 divided by 7. Okay. So here n plus 1 factorial is nothing but n plus 1 times n factorial, and n minus 4 factorial is nothing but n minus 4 into n minus 5 into n minus 6 factorial. Every time 1 is reduced, so here we have n minus 6 factorial divided by n factorial. So finally what we have, n plus 1 whole divided by n minus 4 into n minus 5 into n minus 6. N minus 6 already gets cancelled, so only n minus 4 into n minus 5 is equals to 2 to 7. So do the cross multiplication. 7n plus 7 is equals to 2 times n square minus 9n plus 20. So 2n square we can get 2 9s are 18 minus 18n plus 7n minus 18 plus 7 25n and 40 once again 2 9s are 18, 7n only going that side, minus 25 minus 25n, and 7 is going that side, 40 minus plus 30 there. So we can split this 25 as 6 to 6 means what's that? 6 times 11 or is 22 times 3. So we can write 25 as we can write this 25 as 22n and minus 3. Then calculate the value of n. N should be integer. N should be integer. Next, find n if n plus 1 p5 to np5 is equals to 3 is to 2. Same like above question said. Next, question number 5. Question number 5. This is important question. 56pr plus 6. 56 pr plus 6. That means 56 factorial divided by 56 minus r minus 6. That means 50 minus r factorial. What it is? 50 minus r factorial. Next, into numerator in the down, 54 factorial into 54 minus r minus 3. 51 factorial, which is equals to 30800 divided by 1. Now 56 factorial can be written as 56 times 55 times 54 factorial, and this 50 minus r factorial. 50 minus r factorial we can write as it is. If we do this division, in the division here we can get, first let us take 11 table and we can see, because here 11 5s 55, no? 11 5s 55. Next, here 11 2s 22 and 88 is there, 11 8s 88, 28 00, and here 7 table 7 8s are 56, 7 400 times, 8 1s are 8 50 times. So we are getting 51 minus r is equals to 10. 50 divided by 5 is 10. So r is equals to how much? 14. That's it. Next, 12p5 plus 5 times 12p4 is equals to 13pr. So here 12p5 means what's that? Here let us do here. Already we have done this in the same model question in the above. 12 factorial divided by 12 minus 5. 12 minus 5 how much? 7 factorial. Next plus 5 times 12p4, that is again 12 factorial divided by 12 minus 4, 8 factorial, which is equals to 13 pr, which is equals to 13 pr. Now you can see 12 factorial divided by 7 factorial is nothing but 42. np7 is equals to 42 times np5. Same model question almost. Next question is, find the number of ways of permuting the letters of the word picture so that all vowels come together, no two vowels come together, the relative positions of vowels and consonants are not. Here what is the given word? Picture is given here. So 1, 2, 3, 4, 5, 6, 7. 7 letters are there. In these 7 letters, P is not repeating, I is not repeating, C no repetition, T, U, R, no letters are repeating. But out of these 7 letters, vowels, I, A, I, O, U. So I and E, U also. So I, U, E. These are the vowels. First question, all vowels come together. Take this as a particular set and the remaining 4 letters individually. So totally 4 plus 1, 5. That could be 5 factorial. And internally this IUE can be arranged in 3 factorial ways. So 5 factorial times 3 factorial. Okay, simplify, you can get the answer. Next one is no two vowels come together. Two vowels come together. No two vowels come together means all vowels come together. Already done. All vowels come together, already we have done. Now no vowels come together. First consonants you can arrange in 4 factorial ways. In remaining gaps you can place this IUE. How many gaps are there? 5 gaps are there. In 5p3 ways we can arrange. Next question is what? The relative positions of the vowels and consonants are not disturbed. The relative positions, that means here we have IUE. I is in 2nd place and U is in 4th place, 5th place, and E is in 7th place. In that places only the vowels has to move. Means in 3 factorial ways they can move, and the remaining consonants also in the same way they can move, that is in 4 factorial ways. So totally 3 factorial times 4 factorial is equals to 144. Next question number 3. Find the number of ways of arranging the letters of the word triangle. So here in triangle some repetitions are there, I think. Repetitions are there in triangle definition. In triangle spelling, T not repeating, R not repeating, I, A, N, G, L, E, no letter is repeating here. So again what the question is, what relative positions of vowels and consonants, same like above. First separate the vowels and consonants. Then how many vowels are there in that many factorial ways and how many consonants are there in that many factorial ways? 3 vowels, 3 factorial, and 5 consonants, 5 factorial, 3 factorial times 5 factorial is the final answer. Next question number 4. Find the sum of all 4-digit numbers that can be formed using the digits 1, 2, 4, 5, 6 without repetition. Here number of zeros not present in the given digits, so directly we can use the formula n-1 pr-1 sum of the digits times 1, 1, 1 and so on. So here total number of given digits are 1, 2, 3, 4, 5. 5 digits are given, 4 digit numbers are required. So n is equals to 5, r is equals to 4, n-1 p r-1, that is 5 minus 1 p 4 minus 1, 5p3. 5 minus 1 p 4 minus 1, 4p3, yeah 4p3. And what digit number? 4 digit number. 4 digit number, 4 ones will come. And sum of the digits 1 plus 2, 3, 3 plus 4, 7, 7 plus 5, 12, 12 plus 6, 18. That is the final answer. Next question, question number 5. Find the number of ways of arranging 6 boys and 6 girls in a row. Okay, find the number of ways of arranging 6 boys and 6 girls in a row. Any of these arrangements, all girls are together, no 2 girls are together, boys and girls come alternatively. So first here 6 boys and 6 girls are there. Okay, so here we have 6 boys and 6 girls, so that all girls are together. So take this 6 girls as a one set, 6 boys and one set, so totally 7 factorial ways times 6 girls internally arranged in 6 factorial ways. This is the answer for first question. No two girls are together. First arrange 6 boys. Boy number 1, boy 2, boy 3 and boy 4, boy 5 and boy 6. How many gaps are there? 1, 2, 3, 4, 5, 6, 7. 7 gaps. How many girls are there? 6 girls are there. 7p6. Okay, 7p6 is nothing but 7p6 is nothing but 7. Okay. Next question. Third question. Boys and girls come alternatively. Boys and girls come alternatively. So here, I think in two different ways. First, boy can start or girl can start, right? Suppose here, find the array. First, arrange 6 boys. Not that one. So let us do the third one. The row may begin with yes. This is what I am telling you. The row may be begin with either a boy or a girl. So first you can start with boy and do it, and then you can start with a girl, and then you can do the arrangement. So totally 6 factorial times 6 factorial, but in two different cases it is. So 2 times 6 factorial times 6 factorial. Number 6. Find the number of ways of arranging 5 boys and 4 girls so that the row begins with a boy and with a girl. Second question, begins and ends with the boys. So here we have 5 boys and 4 girls. Out of 5 boys, 1 boy is arranged in the first place and 1 girl is arranged in the last place. In the middle, 1, 2, 3, 4, 5, 6, 7 places are left, and 4 boys and 3 girls, totally 7 are there. So into 7 factorial. Into 7 factorial. Understood? We will first place with one of the boys. Here same they are saying one of the boy in 5 ways, and last place with one of the girl, that is in 4 ways. The remaining 7 places can be filled with 7%, 7 factorial. For first position, how many choices are there? 5. For last, how many choices are there? 4. So 7 factorial times 5 times 4. Begin and ends with boy. There is a beginning and ending with boy. Let us see here diagram. Yeah, see. So beginning and ending with boy. So here we have a boy. Here also we have a boy. So 2 places. Totally how many boys? 5 boys. 2 places with 5 boys. 5p2 ways. Next, remaining positions 1, 2, 3, 4, 5, 6, 7. Out of 9, 7 has gone. The remaining 7 places can be filled with 7 boys and girls in a way 7 factorial. So finally, what is our answer? 5p2 times 7 factorial. Clear? Right. Next, question number 7. Find the number of ways of arranging 5 different mathematics books and 4 different physics books and 3 different chemistry books such that the books of the same subject are together. Find the number of ways of arranging 5 different mathematics books. So take 5 mathematics books as one set and 4 physics books as one set and 3 chemistry books as one set. MPC is there. So in 3 factorial ways we can arrange them, but internally M can be arranged in 5 factorial ways, and 4 physics can be arranged in 4 factorial ways, and chemistry can be arranged in 3 factorial ways. So finally, what is the answer? Okay, this is the answer. Alright, next, problems for practice. Find the number of all 4 letter words that can be formed using the letters of the word equation. So in equation, 1, 2, 3, 4, 5, 6, 7, 8. 8 letters are there. Here E not repeating, Q, U, A, T. No repetitions are there here. How many of these words begin with E? So E we can write here. Yes or no? In the first position we are fixing E. Next, how many positions left? 1, 2, 3, 4, 5, 6, 7 positions are left. 7 positions can be filled with the remaining 7 letters. 7 positions can be filled with the remaining 7 positions. That is for all. But here find the number of all 4-letter words, it seems. 4-letter words means up to here itself we have to stop. Here 1, 2, 3. 3 places are there, but we have 7 letters. 7 letters in 3 places. 73. How many ends with N? How many ends with N? So in the ending N we have to fix, and the remaining is our wish. Again same, I think 73. How many begin E and end with N? How many begin with E and end with N? So in middle 2 places are there. 6P2. 6P2. Next, long answer type questions. Right? So what is the first long answer here? If the letters of the word master are permitted in all possible ways and the words thus formed are arranged in the dictionary order, then find the rank of the word remasked and master. Whatever the word is given in the question, first we have to arrange the letters of the word in ascending order. So here in ascending order, nothing but dictionary order. In the dictionary order, if we arrange the letters, what we are getting? A, E, M, R, S, T. So first let us start with A and we can arrange. A is placed in the first position, then 1, 2, 3, 4, 5 more 5 places are there with 5 letters in 5 factorial ways. Then next we can start with E, again we can arrange them in 5 factorial ways. Next we can start with M, again 5 factorial ways. Next R. R is the required letter, so replace R. Here place R, and again you can search for next letter. The next again we have to come back to A. A is not the required letter. A is not the required letter. So 4 factorial ways. And next A after M. A after E. RE. E is the required position. E is the required place. So here E we can consider. And again we move back and we can see what is the letter. A is the letter. A also required here. And then A after what do we get? A is required. Huh? What is the word? Remaster. In remaster, E we filled and we went back, and there A is there, not M. So A is not required to us. 2 places filled already. 2 places already filled. Then more 3 places will be in 3 factorial ways. Only 3 places will be. That 3 places can be filled in 3 factorial ways. Next, after A we have already E is came, then M. So replace with M, again go back and take A, and again you can take S and again T. So all are filled. This can be done in only 1 factorial ways. So add up all the answers: 5 factorial plus 5 factorial plus 5 factorial, 4 factorial plus 3 factorial plus 1 factorial. That is nothing but the rank of the word remasked. In the master also same. First we have to arrange the letters in ascending, that is dictionary order. Okay, here 6 are there now. 1, 2, 3, 4, 5, 6. So first starts with A. Remaining 5 can be filled in 5 factorial ways. Starts with E. No, 5 factorial ways. Order I can write here: A, E, M, R, S, T. So with A we have done. No. With E we have done. No. Next M is the required. So M place it and again move back. A also required. And then E is not required. 1, 2, 3 again. 1, 2, 3 again. Out of 6. No? So in 3 factorial ways. In 3 factorial ways, then E can be filled with E. The third position can be filled with R. No. Again 3 factorial ways. Next with S. S is required. So place S there. M, A, S. and again move back. In back we have only letter E. So if we write E here, 2 factorial ways. Next E after M completed, A completed, S completed. E after R we have to write. If we write R again 2 factorial. R after S already there. T we have to write. If we write T 2 factorial will come. So M A S T. Here T is the required one. So 2 factorial we cannot write. We can move back. In the back we have letter E. Then we can write E. Then R. That is only in 1 factorial ways. That can be done in only 1 factorial ways. So 5 factorial. How many times? 2 times. 3 factorial 2 times. 2 factorial 2 times. 5 factorial is 122, 40. 3 factorial is 6, that is 12. 232, 232 plus this is a 4, 236, 257 finally. Next question. If the letters of the word prison are permitted in all possible ways, and the words thus formed are arranged in dictionary order, find the rank of the word prison. Same like above. Okay, next to combination. Combinations are nothing but selections. Combinations are nothing but selections. A selection that can be found by taking some or all of finite set of things is called combination. The combinations found by taking two things at a time from a set A, B, C, or A comma B, A comma C, B comma C. See, you can see here we are not taking B comma A, we are not taking C comma A, we are not taking C comma B. These all are not valid in selections, because selecting A comma B or B comma A same, and A comma C and C comma A also same, B comma C, C comma B also same. Next, the number of combinations of n distinct things taken R at a time is denoted by NCR. And NCR formula, n factorial divided by n minus R factorial times R factorial. How do we get that? By dividing NPR with the R factorial. If we divide NPR with R factorial, we can get that answer. Next one is, for any positive integer NCN, for any positive integer NCN, NC0 is 1, NC1 and NCN minus 1, this is also n. And if R comma S less than or equals to n, if NCR is equals to NCS, then R plus S is equals to n, or else R is equals to S. Next, NCR is equals to NCN minus R. NCR is equals to NCN minus R. Yeah, for this is continuation, I think. Next one is NCR minus 1 plus NCR is equals to n plus 1 CR. NCR minus 1. What is this property? NCR minus 1 means what? N factorial divided by n minus R minus 1. That means plus 1 factorial into R minus 1 factorial plus n factorial divided by n minus R factorial into R factorial. So here n factorial by n minus R. Okay, n factorial by n factorial by n minus R factorial into R factorial taken common. This is 1. Here only n minus R plus 1 is left. And next R minus 1 also left. R minus 1 plus 1. Simplify this. Here R plus 1 will come. Here n minus R plus 1 will come. Plus or minus 1 gets cancelled. Plus or minus 1 gets cancelled. What we are getting? N plus 2. N plus 2 we are getting. Divided by n minus R factorial into R factorial. Divided by n minus R factorial into R factorial. So n factorial into n plus 1 divided by n minus R factorial into R factorial. Okay, so what do we get? We can get n plus 1 CR. Here n minus r into n minus r minus 1, that is n minus r minus 1 factorial, and r factorial into r plus 1 factorial is r plus 1 factorial. Next, NC4. NC4 is equals to NC6, then find N. NCR is equals to NCS formula is then also apply this formula. NCR is equals to NCS formula. So you get N is equals to either 10 or N, R is equals to S. Next, if 10 times NC2 is equals to 3 times N plus 1 C3, then find N. 10 times NC2. N factorial divided by N minus 2 in N minus 2 factorial into 2 factorial is equals to 3 times N plus 1 factorial by N plus 1 minus 3 factorial times 3 factorial. So 10 times N factorial divided by N minus 2 factorial times 2 factorial is equals to 3 times N plus 1 factorial divided by N minus 2 factorial times 3 factorial. So here we are writing N plus 1 factorial as N plus 1 into N factorial, because both ways N plus factorial, N plus N factorial gets cancelled. Then 10 times N minus 2, N minus 2 factorial, N minus 2 factorial also gets cancelled. Here 2 factorial times 3 factorial, 3 into 2 factorial gets cancelled. And here this is the 3 also gets cancelled. What is left finally? Finally we get 3 times N plus 1 is equals to 3 times 2 times 1, that is 3 gets cancelled, 10 is it. Finally we are getting N is equals to 9. We can get N is equals to 9. Next to find N and R. If NPR, find N and R if NPR is equals to 1320 and NPR is equals to 220. So substitute the values. NPR is given, NCR is given. What is the relation here? NCR is equals to NPR divided by R factorial. So substitute the values. NCR is 220, NPR 1320 divided by R factorial. 0 gets cancelled, and this is what 11 2's, 11 ones, 11 2's. So R factorial is equals to 6, R is equals to 3. Next, NC5 is equals to NC5 is equals to NC6, then 13CN. NC5 is equals to NC6 means N is equals to either 11, is 11 only. N is equals to 11. Then 13C11, 13 times 12 by 13C11, 13C2, 13 times 11 by 2 times 1. Find the value of 10C5 plus 2 times 10C4 plus 10C3. So 10C5 plus 2 times 10C4 plus 10C3. 10C5, again 10C4 one pair, then 10C4 and 10C3 one pair. NCR plus NCR minus 1. NCR plus NCR minus 1 is N plus 1 CR. So 11C5 and 11C4, that is nothing but 12C5. Next, question number 7. If NPR is equals to 5040, NCR is equals to 210, then find the N and R. NPR is given, NCR is given. In the above, we written also the relation between NCR and NPR. From that, you can get everything. Next, to come to short answer type questions. Prove that NCR minus 1 plus NCR is equals to N plus 1 CR. Just now we proved in the above, this one. Okay. Next, find the number of ways of selecting 5 books and 9 different mathematics books such that a particular book is not included. Total number of books are 9. 5 books we have to select. Okay, particular book is not included means only 8 books are there. From that 8 books, 5 book selection, that 8C5 is. Number 2. Number 3. Find the number of ways of selecting 3 vowels and 2 consonants from the letters of the word equation. So equation, no repetitions are, yeah. And vowels are E, O, U, A, I, and the consonants are Q, T, N. Number of selecting 3 vowels from 5 vowels. Number of vowels selecting. Number of selecting 3 vowels out of 5 vowels. 5C3. The number of selecting 2 consonants from 3 consonants is 3C2. Total number of selections 5C3 times 3C2. Question number 4. What is question number 4? Find the number of 5 letter words can be formed using 3 consonants, 2 vowels from the letters of the word mixture. Here mixture totally MIX3, TU or E4. Totally 7 letters are there in that. The vowels are I, U, E, 3 vowels, and consonants are M, X, T, R. The number of ways of selecting 2 vowels out of 3 vowels is 3C2. The number of selecting 3 consonants out of 4 consonants is 4C3, and the total answer is 4C3 times 3C2 times 5 letter words from 5 factor. Next, long answer type. That's about short answer type questions. Now let us see what are the long answer type questions here. First question is 25C4 plus R is equals to 0 to 4, 29 minus R, C3. So 25C4 plus summation sigma. Expand this sigma 29C3 by substituting R equal to 0. And if R is equals to 1, 28C3. If R is equals to 2, 27C3. If R is equals to 4, 25C3. So in the above we use the formula Ncr plus Ncr minus 1 is equals to n plus 1 Cr. Same formula if we apply here, first 25C4 25C3, that is nothing but 26C4, and again 26C4 with 26C3, 27C4, 27C4 with 27C3, 28C4, 28C4 with 28C3, 28C4, 28C4, 29C4, 29C4 with 29C3, 30, 30C4. The final answer is a 30C4. Nothing but 30 times 29 times 28 times 27 divided by 4 times 3 times 2 times 1. Okay. Next, let us see the question number 2. 34C5 plus summation R is equals to 0 to 4. 35C5. Let it be, and R is equals to 0 to 4. R equal to 0. 38C4, 37C4, 36C4, 35C4, and 34C4. So 34C5 is there. Here we have 34C5 plus 34C5 plus 34C4. 34C5 plus 34C4. It is nothing but n plus 1. 35C5. 35 n plus 1 CR. 35C4. Now 35C4 again. 35C4. Okay, 35C4 plus, this is 5, 35C5. 35C5 plus 35C4. Again, this is 36C5. 36C5 plus 36C4. 36C5 plus 36C4. 37C5 plus 37C4. 38C5 plus 38C4. 59C5. 39C5. That's about the topic called combinations. Okay. Once again, go through it. If you have any doubts, ask me. After probability, theory of equations in complex numbers, this is what we have to do. De Moivre's theorem. After De Moivre's theorem, we have to go through this topic. 12CR is equals to, here 12CR is equals to 12C 3R minus 5. No? So what are the possibilities here? 12 is equals to R plus 1 plus 3R minus 5. This is one possibility. Or else R plus 1 is equals to 3R minus 5. This is one possibility. In this possibility, what we are getting? 12 is equals to 4R minus 4. 4R is equals to 16. R is equals to 4. And 2R is equals to 6. R is equals to 3. So R is equals to 3 and R is equals to 4. find R. This is R sub, find R. Next, yeah, fourth one already done. Fourth, fifth, sixth, and seventh. Here, what is the relation between NCR and NPR? NPR divided by NCR is equals to R factorial. So here NPR is given 5040 divided by NCR 210 is equals to R factorial. 0 gets cancelled. 504 divided by 21 is equals to R factorial. 504 and 21, 3 sevens, 3 ones, 3 6 are 18, 3 8s are 7 ones are 7 2 is 14, 28 4s are. So 24 is equals to 8 factorial, 4 factorial is equals to R factorial. R is equals to 4. R is equals to 4. After writing R is equals to 4, what is N? NP4 is equals to 5040. NP4 means what? 10 times, 9 times, 8 times, 7. That means N is equals to 10. N is equals to 10. And already we have seen this proof also. Right? This is also done. Yeah, we have done this also. Vowels and consonants questions are there. Concentrate on there. Concentrate on the questions. Next, long answer time. That's it. That's it for today, I think. Yes, that's it for today. Alright, that's it for today. In the next class, we can see the next topic. Okay, students. Bye.